Hi, everybody. Thanks for attending. My name's Marty Schock, and I'd like to introduce to you the Bluge Indexing and Search Library.
I'm going to start with a brief history of Blovey. Many of you on this call are probably already very familiar with Blovey, but just to set the full context, we launched this project back in 2014. It really originated to become a engine for search inside of the Couchbase server release. It ultimately did become sort of a part of the release back in 2016, Couchbase server 4.5. And really from the very beginning, we've tried to focus on building Blovey, like not just for Couchbase, but as this thing that could also serve the community. And that brings with it a bunch of challenges. You're always trying to balance, the community needs versus Couchbase's needs. And again, I think we've done that pretty successfully, but it's an ongoing challenge. And I would say frequently issues come up where we have to revisit how we manage that balance. One of the major milestones in the library in 2017, 2018, we sort of rewrote the whole indexing tier with something called Scorch. That was a major activity for the project, and really, I think, again, kept it relevant, right? I think at that time, Blovey was not very performant. It had a bunch of limitations, and we'd really just, it was something that had to be done to stay relevant, and we did it. Similarly, in 2019, the Go community has sort of adopted Go modules now. I would say there's some consistent backlash to it, but generally things have just moved forward with Go modules. And we finally made the decision that it was the right time for Blovey to also adopt Go modules. And again, I see that as something where it was something we kind of had to do to stay relevant in the Go community. And so again, we've always had this history, I think, of trying to stay current, stay relevant. And I included this chart here on the right that shows, so that's the GitHub stars over time. It shows we've just had a pretty steady growth, steady popularity. We have a fairly popular Go project in Blovey. And that's why I think it's important that we keep an eye on that and make sure we're doing everything we can to stay current and stay relevant. So today I'm here to talk to you about something different, something called Bluge. Well, what is Bluge? As I said, it's a new Go library for indexing and search. It's built really using the core of Blovey. I want everyone to be very clear. This is not a rewrite. I've been around the block enough times to know that anyone that says, "Oh, I have this thing and I'm going to improve it by rewriting it," fix all the things I know are broken. That never works out, right? You may fix the things you think you know are broken, but you end up introducing a whole new set of bugs. And so I've tried to be mindful to not go make a wrong path there. But again, look at it as a series of iterations on Blovey, right? Keeping all the unit tests that are still applicable intact, and using it as a continuous transformation where I'm sort of always trying to keep it in this known good state. And I really think we got the best of both there. We kept the really good parts of Blovey and we're able to technically sort of remove and change the things that we felt needed to be changed. Again, this is based on my years of leading Blovey and working with Go. There's a number of changes that I wanted to see made. One of the things I've learned over the years is that Blovey is now used by many different companies in production. And that's great. That's awesome. And that's, again, a testament to the success of the project. But it comes with it some other challenges, right? There are certain things that sort of slow down a project once you're in that situation, right? Companies need backwards compatibility. You can't break the index format when you have indexes on customer machines that are built with an older format. You've got to have a story for that, right? And so sort of necessarily things iterate slowly. And that's really why I think the power of Bluge here is it's an opportunity, as I say, to look several moves ahead, right? These are all things that could be done to Blovey, but it's doing 7 or 8 or 9 of them all at one time, which if we were to introduce them to Blovey might take us several years at the current pace, right? And so the idea was, one, new projects could adopt Bluge right away and get all of these things at once. And also this can guide Blovey, right? Like a Blovey user who says, you know what, I'm just not ready to adopt Bluge, but I really like that one feature. Let's prioritize getting that into Blovey. So it can serve as this guide of what are the most important things to bring to Blovey next. And again, I think it can serve both of those purposes. So with that said, let me press buttons on the right computer. Let's move to the agenda. Again, I'm going to start by talking about some of the things I've removed from the Blovey code. Then we're going to talk about some of the cleanup and changes I've made to the existing code. And then finally, I'll shift to some of the enhancements and additions. And then again, we'll look at, I think I changed the order since I updated this slide, but then we're going to do a demo. And then finally, we'll wrap up looking at the future and where we go from here. So to start, removing code. One of the major things we wanted to remove from the very beginning was the index mapping. Might be a little surprising. It's kind of a core feature of Blovey. If you're not familiar, the JSON you see on the left-hand side is a JSON serialization of a Blovey mapping. And what we find is, just to reiterate, this is what takes, it sort of describes how we take objects from your domain model and turn them into fields in the index. And while that's an important thing, and I wouldn't suggest that's ever going to go away, what we found is maybe that doesn't belong in Blovey. And the reason is, when you have strongly typed objects, you generally have a very explicit thing you want to do. I have a field called name. I want to do this with it in the index. That's sort of the simple case. When you have unknown data, like let's say you take JSON documents from a customer and you need to sort of dynamically do things with that, what we found is it's really hard to all agree on what those rules should be. For some scenarios, it makes sense to take this field and turn it into text. For another customer, maybe it makes sense to do something different. And so the Blovey mapping has been this thing where it's been difficult to, you know, keep that operating in a way that everyone agrees that's how the mapping should work. And like I said, the escape valve is just adding more options, but that just makes it more complicated. And again, different inheritance rules. Again, it's just sort of really gotten to be this heavyweight thing that shouldn't be that heavyweight. And it's mainly just because we're trying to do too many things for too many people. So what does Bluge do as an alternative? On the right-hand side, you see we basically just allow you to, through code, explicitly say what you want done. The example I show here is I'm creating a new document with the identifier A. I'm adding a field. It's a text field. It has the field name. The name of the field is name. The value for the field is Marty. And again, I'm using other methods like store value to set any of the options we're doing. Now you see the last field there is a composite field. So again, we still support fields like the all field, again, in a little bit more flexible way. But again, the idea is you have Go code and you express through your Go code explicitly what you want to do in the mapping. Again, applications may need to serialize the mapping anyway, but again, that's something that would be done at your applications level, not at the Blovey level or the Bluge level. So again, we've removed the index mapping and replaced it with code that you see on the right-hand side. Another major thing we've removed is something called the query string. Again, I put these early because these are the ones that are probably the most surprising. It seems like very simple functionality, right? And I would think most people look at it and they think, okay, fine, why would you remove that? Everybody likes being able to just type in a string and have you be able to create a somewhat complicated query based on it. And the trouble is, while the syntax seems very simple, there's a long history of the community not agreeing on how the query string should work. And really, one of the things that I found is I had sort of always believed that a high quality application is going to want to take ownership of the query string anyway, right? You're going to know what fields your application uses. You're going to know what types those fields are. You're going to know what sort of business logic and business rules you have around those fields. And all of that feeds into a better query string for the user of your application. A general purpose query string, while it seems desirable, I think is, again, just effort put into the wrong place. And so what Blovey has done, or what Bluge has done, is we've taken the query string and we've moved it up out into its own module. So it still exists for the people that want to use it in the current form. I think this is something where there'll be some more innovation from my perspective to make better query strings that are, again, customizable to the particular application. But again, for now, the query string itself has been removed from Bluge. Another item we've removed is JSON marshalling. So what you see here is the search request structure from Blovey. And you notice on the right-hand side, all these JSON colon. Again, that's a built-in feature of the Go language to allow us to describe sort of in line with the structures how a JSON marshaled version of this would look. And again, it's very convenient. It seemed like sort of a great use of the language feature to do that. But what we found over time is it really sort of encourages an anti-pattern. What it encourages is an application to sort of directly expose the Blovey search request as a part of their own API. And again, from my perspective, that's actually an anti-pattern. What we realize later is, let's say Blovey decides, hey, you know what, we should really make, I don't know, we're going to change the type of the from field from an integer to something else, right? I don't know what that would be, but let's say we wanted to make that change. What we find is, oh, well, now we're kind of stuck with it because an application has been built using Blovey. They've directly exposed it. And so now we can't change that type. And so to me, the real takeaway here is it sort of causes people to confuse the needs of the search library, right? We want to be able to make changes to this as we need to keep Blovey being the best search library possible. And that really shouldn't have any downstream effects on on applications. And so again, I think removing these JSON serializations basically just enforce the fact that your application should be owning those structures and those JSON serialized versions of them, not the Blovie library itself. And again, it doesn't mean that you will still need a JSON serialization of a search request likely, but in all likelihood, it's going to be different than the one we would have given you anyway. Related to that, Blovie had traditionally offered some HTTP handlers. These did the basic operations of creating an index, indexing documents, deleting documents, executing a search. And again, they all work directly with those JSON serialized data types you saw on the previous slide. But again, what we found was in practice, while these were useful examples, almost no one used these anyway. And the reason is, look, in the real world, you tend to not just expose search directly as an end user operation on the underlying index, right? You tend to have again, business logic enforcing various constraints, security features that you want to add, and we can't just always decorate those around these handlers. Oftentimes, you really need the core logic to be under your control. So again, even Couchbase didn't necessarily use these HTTP handlers, and so it just seemed like the right time to go ahead and remove those. They're not really serving any purpose for the library. Another capability we had in Blovie was a registry package. The basic functionality of the registry was that you could take pieces of code, often it was usually in the analysis pipelines of things like analyzers, token filters, and so forth. And you would be able to give them string identifiers. And the real goal here initially was that an index could be sort of self-describing. If I have a mapping and the mapping refers to these registry components by name, and then we put the mapping inside the index, the sort of the grand theory behind all that was, if someone just handed you an index, you would know what you needed. But in practice, that wasn't particularly useful. And the reason is, in Go, we'd have to have all that functionality compiled into the application in the first place, or else we still can't use it. Even if it's self-describing, all it would tell us is that you can't work with it. And so in practice, this wasn't particularly useful, and it led to a lot of non-idiomatic Go code, right? And so what happened was you would find places where you want to invoke an analyzer, and you would be using the string reference as opposed to just invoking a function, right? And so in Bluge, we have done away with the registry. Again, like a lot of these, there's a common theme here. Applications may still need to have a registry where they have that mapping of textual names for pieces of code. But again, if you think about it, it just sort of makes more sense that that registry would exist at the application level and not at the library level. So again, it's something that we were able to sort of remove. It removed a lot of boilerplate code and ultimately, I think, helps clean things up going forward. All right, finally to some core indexing changes. Blovie supported a feature when indexing something called array positions. Again, it sort of came out of the idea that we would be indexing potentially hierarchical data with nested objects and arrays, and that when you had arrays, it would often be useful to sort of record the position that a particular value came from in its original array. And again, this shows up in two places. One is in the actual index. And it turns out while Blovie indexed the array positions, we didn't offer any searches that used it, right? The one exception being a phrase search would use it to sort of make sure you didn't match across a array boundary. But there was no real search that expressed like relative positions in the arrays or anything along those lines. And so really it was taking up space and bloating the size of the index, and we didn't offer any real value that came along with it. And so that's been removed from the indexing side. Now, it also would be a part of the stored information. So if you stored a value, the stored array positions could be used to, when you return that value from the index, we could sort of try and reconstruct the original sort of structure of the array. And that was used, I'm sure, by certain customers and users of Blovie. And so that is something that we're removing the capability, but really what we're really not, because sort of in Bluge, we're basically taking the position that stored values are just opaque binary values, right? We don't try and interpret anything based on them. You store a binary, we return it back to you. So it means if storing the array positions is that important to you, you can always just encode that information yourself in the byte slice that you store. And then you just have to know to decode that slice correctly on the way out. And that's something we could even provide helpers and handlers for in the future if it proves useful. Now, going forward, although Bluge has removed array positions, our hope is that some of the real power that you want to have with nested objects and arrays can be made available in a different functionality. So Lucene has a notion of child documents, and that's something that we're thinking that the new index is actually may be able to support that model. We do not support it today, just to be clear, but it's something we'd like to look at, being able to support the child document model as a way of hopefully efficiently, delivering some of the same functionality that we're giving up by removing array positions. All right, so that's the major pieces that we've sort of taken out. Actually, one more I didn't have a slide for. Bluge had the notion of supporting internal keys and values. It was sort of like a nested key value store inside of the index. And we've removed that capability as well, mainly because what we found is it really duplicates something that you can already do with Bluge, right? If you want to store sort of private keys and values, you can do that through stored fields and just treating them as separate documents inside of your index. So now let's move to some of the cleaning up the code sections. One of the sort of themes that I tried to do in just sort of simplifying the way the code base works is adopting this principle that's out there in the community of fewer, larger packages. So an example here is you notice on the left-hand side, we see a list of what I believe are token filters. And each of them in Bluge is a separate package. And then those packages tend to only have one or two files, often one file implementing it and one file for testing it. And what we found is there's really no benefit by having these in separate packages, right? It's sort of, we started with this notion of everything gets its own package, and there really was no gain. And the reason is, one of the main reasons you really want to separate things into different packages is if there are different dependencies involved, right? Where you want to include one piece of functionality, but you don't want this unintended dependency. But in practice, we found almost all of these are just using core standard library functionality. They don't have any real dependencies. And so having them in a single package just makes more sense. They don't have any naming conflicts anyway. They all had very unique names. And so again, this is a good example where we were able to take 15, 16 packages on the left-hand side. And now we just have one package with just more files in it. And again, from the user, I think, and the maintainer, it's really just a little bit simpler to work with. Another big change, we're moving to strongly typed configuration. So I have an example on the left-hand side of a index feature called unsafe batch. And I've illustrated how you would, or internally, how we sort of check that option. And that already highlights one of the big problems. A lot of these config options you wouldn't know about unless you sort of browsed the code and found that we looked for a particular string value and honored it in a certain way. We didn't have a really good way to communicate and document those config settings. So in this case, again, there's sort of a magic string unsafe underscore batch. If you knew to use it and you set the type to Boolean, you would be able to toggle the switch internally inside of the Scorch index. And so again, it highlights another issue, which is there can be type safety issues. Now, in this case, it's coded in a relatively safe way, but there are other cases where we had encountered problems where someone would pass, they parsed it as JSON, and so it was a float 64 value, not an integer, or the other way around, and we would have issues. So it just wasn't a particularly good way to do configuration. On the right-hand side, you see how we do this in Bluge today. The config, you notice, is a strongly typed object, not just a map. And we have methods, like in this case, with unsafe batches, which are used to sort of toggle these switches on. And again, it ends up being a much cleaner way to do it. It has the advantage that when you're writing code, your IDE can sort of autocomplete. If you say, with unsafe, it's going to autocomplete to batches. So it has that nice integration there. The only downside really is that with the strings, we could sort of add them whenever we wanted and not have to worry about breaking compatibility, right? But that's, there's two sides of the same coin there, right? That was convenient at times as sort of an escape valve, but it also leads to the problems we've already talked about. Our hope is now that we're using Go modules, we're going to be able to iterate the versions, the config structures using the versioning the semantic version that we can use to communicate any of the breaking changes. And hopefully that proves a way of sort of giving us the best of both. Linting all the things. So one of the bigger observations is just the Go community has sort of matured over the years. I mentioned that we started Bluge way back in 2014. Things have come a long way. One of the things that's really popular in the Go world is static analysis. And I have a list here. That list on the right-hand side is not just a list of tools that are out there. Those are the ones that are actually already integrated with Bluge, right? So these are things that are going to be wired up and running from day one. And then I have on the middle here, on the left-hand side, you can sort of see this gives us sort of a first pass code review, right? When anytime a pull request comes in, these are tools we're going to be running on all the changes coming in and help us, give us that first bar of, code quality coming in. It gets us out of the situation of Marty doesn't like your white space as opposed to a tool saying, hey, your white space isn't consistent with the rest of the project. And again, effort was put into making sure Bluge passed all these things from day one, right? So we're not holding new code to any higher standard. All the existing code is passing the same set of rules that we're checking for new code. All right, finally, probably the things people are most excited about. Let's start talking about some of the new features. What are the real benefits and reasons to switch to Bluge? So the first major thing I've introduced is something called a directory abstraction. Previously in Bluge and Scorch, and then its file format called Zap, all three of those layers would have operations which talk to the file system, right? We had a index meta JSON, which the Bluge level talked about and managed. There was a root bolt structure that the Scorch level would manage. And then finally, there were the Zap files themselves, which the Zap library would directly manage. So all three of those tiers directly went to the file system to do things. And really that proved limiting, right? What we found was, a good example was we had built Scorch with the notion of working with files that were memory mapped from the very beginning. And then, fast forward, 12 months down the road, someone says, wouldn't it be great if we had an in-memory version of Scorch? And you realize, oh, we kind of baked the file idea into everything, right? And so, option one, you can go through and every place you're dealing with a file, have a new flag, like, is this an in-memory mode? And then have separate logic to do things differently. That's obviously got some big drawbacks to it. And so the alternative was to introduce something like this directory interface. And the idea is any place where the code was previously dealing with a file and making the assumption that it even was a file is now going through this directory interface. And the directory can be backed by different things. Out of the box, we're shipping with a file system directory and an in-memory directory. But we already know there's use cases where you might want to have various other alternatives. And because this is an interface, and because this is exposed to the configuration system, it means applications can have their own custom directory implementations, obviously that meet certain criteria, and pass those in, and Bluge will be able to work with these as well. And as I said, that sort of gave us, once we sort of refactored things to go through this interface, it gave us an in-memory index essentially for free, just by having a slightly different and much simpler directory implementation, which only keeps things in memory. Another major enhancement is multi-process index. Almost anyone who has shipped a product using Bluge has run into this at some point. Today, Bluge holds a sort of exclusive read-write lock on the entire index. And that means you can only have one process working with your index. If you need to have another process access index, you end up having to use inter-process communication either over the network or some various socket or something to do that, right? And so it gets cumbersome. And while that may be appropriate for some use cases, it's a really heavyweight solution for a lot of other use cases. So what Bluge introduces is using the operating system file locking capabilities to sort of navigate multiple processes working with the index at the same time. The design we think is not super revolutionary. We're basically inspired by the way Lucene and SQLite try and navigate some similar issues. The basic idea is you can have one read-write process, which will get an exclusive lock on the files that it needs. And we can then allow multiple read-only processes which work with the disk-based version, right? So that read-write process, if you think about it, because the process that's doing the writing has various in-memory structures, sort of as it's as it's in the process of updating the index, and those structures are designed so they can be searched, right? Some of the data is still in memory; it's not yet on disk. That read-write process can search that latest data. But these other read-only processes, they don't have access to that, right? They're out there in a separate process space. So the read-only processes are only able to search the most recent data, which has been, a snapshot persisted onto the disk. Again, we think that's still a very useful capability, and obviously, although there are differences in the latency for accessing your data, still highly useful. And we'll see how this feature and the previous one really come together and combine in interesting ways. A couple other features we sort of get for free out of this. And the next one, you get to one of them right away, actually, backup, right? So Bluge today has no online backup capability. And because of the fact that the read-write structure we're using for the metadata of the index is a bolt DB, you basically have to shut down your Bluge index in order to safely take a backup of it today. Could we address that? Could we make some improvements? Yes, there's ideas in progress on how we could do that, but it's a pretty big limitation in Bluge today. And really just to emphasize how that this feature is really enabled by the directory abstraction. I've actually been able to include the entire function for backup in Bluge right on the screen here. So as you see, it's only about 15 lines. The basic concept is you've got a snapshot open. It could be one of those read-write snapshots, or it could be a read-only snapshot. This capability works with either. Uh, and so that's sort of the source, is the index that you have open, the snapshot. That's sort of the I in this particular function we're seeing here. And then the backup takes a remote directory, right? So if you think about it, it's almost like we're copying data from one directory to another, and using the directory abstraction, that's exactly what we're doing. Um, Again, the index snapshot has two basic pieces of things associated with it. The first is the segments. So we're really just ranging over the various segments. We're using the persist method on the remote directory. Again, so basically we're writing the segment to the remote directory. We do that for each of those segments. And then we need to persist sort of the metadata about the snapshot itself. So now we use the persist method with the kind set to snapshot and pass the snapshot information in as well. So as you see, it's really simple. I'm not lying. There's really no other code here. This is how the backup works. To me, it's a really good example of how having a few of the better or improved abstractions in place really give us important functionality in not very much code. Oh, I meant to highlight one other thing. If it wasn't clear, this also means you can take not just a backup, but take a backup out of process. And again, I'll be demonstrating that capability later on as well. So those features work together. Another major enhancement, Bluge today uses TF-IDF scoring, and Bluge has moved on to BM25. Conceptually, they're pretty similar. They both work with the notion of how frequently does a term occur relative to how in one document, let's say, versus how frequently that term occurs in the entire population of documents. Two major things in BM25 is there are some parameters. The first is K1, that's a term saturation parameter. The way to think of it is in TF-IDF, if a document uses a term more and more frequently, that sort of has an unbounded influence on the final score. Whereas in BM25, there's a saturation parameter, right? You're never going to exceed this K1 value, no matter how frequently the term is used. You'll approach it, you'll get closer, but you'll never get there. That's really useful when you start talking about combining scores from multiple query clauses, right? It means the math to sort of sum up individual scores sort of makes a lot more sense. You can sort of reason about that a lot better when there's a saturation parameter in place. The second parameter, B, really works like the normalization factor, but in TF-IDF, it was sort of like, do you want to include the norm factor or not? B gives us sort of a dial, right? If we set B down to 0, we're ignoring the norm factor or the field length, and then we can tune it up to increase the effect of the field norm. So again, it's a sort of another tunable that we get. As I said, so Bluge supports BM25 out of the box. But more importantly, Bluge introduces a few more interfaces to make the scoring configurable. As I mentioned, BM25, that's implementing that first interface you see here, something we call a similarity model. And I separated out similarity from scoring because similarity has an effect on the indexing phase as well as the search phase. So BM25 is in sort of in the terminology, it's a similarity model that also controls how we score terms at query time. So there's a sort of a pairing of how we index the information with how we score it. And then there's other interfaces at a higher level. There's a scorer and a composite scorer. And these sort of pair up with the different kinds of queries. Again, I'm not going to go into full detail here, but the basic idea is different queries will take composite scorers and scorer interfaces and allow you to customize how you score a particular query. Again, this is really something that gives you a lot more power. In Bluge, everything was sort of hard-coded. A term query was scored a certain way. A disjunction was scored a certain way. And you didn't have the ability to change that. These give you the ability to plug things in. And again, will give us a lot more flexibility going forward to ultimately give custom scoring to the end user. Another really cool feature, Bluge introduces a concept of a virtual field. So the way to think about a virtual field, it's something you'll specify in your configuration when you open up an index. And they are fields, but they're not physically a part of the index. So traditionally, fields are indexed along with as a part of documents in the index. And these are going to behave so it's basically like you can define new fields at the time you open an index, and all documents behave as if they had these fields, even though it's not physically there. Supports all the features of real fields, right? You can use the same analyzers to configure them. You can have stored values, indexed values, doc values, they're all supported. And that really translates to, you can search these values, you can load the stored fields, and you can sort and aggregate on these as well. Again, I'll give an example of this, which maybe makes it more clear, but I'll just give two use cases. Let's imagine you're going to partition your data by type, right? I have, and we'll see later in the example, we have beers and breweries. I can create separate indexes for beers and breweries. I can create a search which is going to search across both of them. But obviously, there's times where I want to know if a particular search result is a beer or a brewery. One option is I could have physically indexed a type field along with those. That takes up space in the index. The alternative is I could, upon opening these indexes, have a virtual field set to the type beer for the beer index and set to the type brewery for the brewery. Again, I'll show you code where we see that example as well. But I think there's even more powerful examples here. If you find use cases where you're partitioning by time, let's say every month you create a new index, you could, for example, virtually index the date boundaries of that index, right? That means now you could run a query. You might run it over several, let's say, shards, because that's how you've written the code to execute your query, but it could then match and be searching based on the time dimension as well. So again, there's some really powerful features there again, and that highlights it's not limited just to text fields, right? It works for numbers, dates, geopoints as well. All the core fields that we support in Bluge are also supported as these virtual fields. All right, the final major new feature that we've got in Bluge is something called aggregations. Bluge had a very basic capability called faceting. It basically gave you three capabilities: term, numeric, and date range buckets on a field. And then it would be able to count how many items were either using that particular term or fell into a particular numeric range or date range. And that was it. There was a lot of people had asked for more capabilities than that, but that was really all we had made available. Bluge offers what we call actually an expanded aggregation framework. And so the idea here is we still have the same term, numeric, and date range capabilities that work on various source fields. The whole notion of a source, though, is a little more powerful. In Bluge, all those things I described, term, numeric range, date range, they only work directly on fields in the index. In Bluge, we've abstracted them to work on sources. One source would be the field value itself. Another source that's available to you is the document score. But even more powerful than that, you can have custom functions that build these sources, right? Which means you can chain these together. You could have one that accesses two field values, sums them together, and does some computation on that. Or you could filter the values if you want to exclude certain values. That could be what your function does. So again, there's this new additional layer of abstraction called a source that gives us a lot more capabilities. We've expanded the metrics. Obviously, count is still there, but we also have min, max, average, and weighted average. Those obviously work on numeric things, not on things that sort of go beyond just what you would count. We've introduced some advanced metrics. We have cardinality estimation, which is done in a space-efficient way using hyperloglog++. We have quantile approximation, also something that generally takes a lot of space to compute exactly, but we're using this tdigest library to do that in a space-efficient way. And so those are powerful sort of aggregations that all fit into this new framework. And the real power here is not any of these things individually is sort of cool, but the real power is you can nest these, right? So I could, for example, create complex aggregations and then have nesting complex aggregations inside of those. And just to illustrate that, I thought it'd be helpful to give an example. So again, we'll actually see this live in the demo, but just to briefly introduce the feature. We've got the beer sample data set. It has beers and breweries. This example is only going to be working with the beers. And we're going to start with the terms aggregation on the style field. We've indexed that with the keyword analyzer. So again, that's important because you see there are spaces in the name of the style, and we want to treat those just as a single token. So again, to understand this first level, if you're familiar with SQL syntax or Nickel syntax in the Couchbase world, this is like a group by. It's like saying a group by on the style is sort of the outer level thing. And that count column you see is how many items fell into that particular bucket when you did the group by. Now, the real power here is I'm able to attach the quantile approximation to those buckets that are created, right? These buckets are created dynamically based on the data that we're seeing when we do the group by. And then we're able to compute this metric on those dynamic buckets as well. So again, we've attached, in this case, I've attached the median and the 99th percentile to those buckets. And it makes sense, right? That different styles of beers are going to have a different distribution of alcohol content sort of relative to that particular type of style. Yeah, so I have code here on the next slide. I'm actually going to skip through it because I think it's clearer if we look at it in the editor when we do the demo phase. So we'll just sort of breeze through this and look at that in the next section because we're going a little long. All right, so now we're ready for the demo. So let's start by getting on a full screen here. And we're going to go to a screen that I can't find. So the first thing is the demo we're going to look at is a beer search application. Now, just to show everybody that this is real, I think I actually stopped it. So this is the beer search. It's up on GitHub in the Bluge Labs repo alongside all the others. Just quick cat the go mod. So again, it's using the latest version of Bluge. And yeah, so I'll just build it again. I think it's already built, but we'll build it again. Just gonna run it. So it's listening on 8094, and if we go back to the browser, we're running locally here on 8094. Let's just make sure it's alive, and it is. I don't want to spend too much time. The beer search hasn't changed that much over previous examples, so let's just say name : Bud. That should match some Budweiser beers. We see it match 7 beers. I've cleaned up the interface a little bit, make it look a little fresh, a little more modern. It has aggregations working on the right-hand side. So let's say we wanted to filter that to like medium alcohol by volume. That reduces it to those 3 results, sort of in the medium 3 to 5% range. Again, not going to spend a whole lot of time here because this is probably not that interesting, but it again demonstrates how you can have a sort of end-to-end application, take some documents, and build a search capability on it. What I'm going to shift to is looking at some of the other features that we talked about that are different and unique to Bluge. So we're going to leave that running. I'm going to go back to the terminal. So I have different tabs open here. I hope that's somewhat clear. I'm going to switch. So the application is still running, and I'm going to, this is just another tab in the same directory. I'm going to run the same program again. Now, if I run it again with no other arguments, you notice that's trying to start a read-write process. We only allow one of them. So this just illustrates, it says unable to obtain an exclusive lock. So you can't open a second read-write instance, but that's okay. That was really just to illustrate the error message there. If I notice, I have a command line on here which will run a particular search. So I have another parameter called test search. And again, this is just hacked in to illustrate this particular feature. If I run test search, this is able to run a search on the index while another process has the read-write lock, right? So this is actually producing the example data I just showed you for that group by. So it does a search, and we can actually look at the code. I can remember which screen it's on. And I'm going to open up the main.go, and I'll make the code bigger, don't worry. Okay, so if we have that test search parameter coming in, we're executing this code. You notice we're opening a read-only reader, right? So this is, again, not trying to open in read-write mode. It's just opening a reader. The query we're running is searching the beers. It's going to be looking at the beers index only. I should mention that as well. So the index we opened is the beer configuration. Beers and breweries are indexed separately. I probably should have called that out. Beers and breweries go into separate indexes, so we're only going to be opening up the beers. We open it read only. The query we're going to look at, you notice it's not just a match all, which you often would do for a query like this. I wanted to filter out the beers that had an ABV of 0, and I set inclusive to false on that lower bound. And it was mainly because there were so many beers that had 0, not because it was actually like an alcohol-free beer, but because they didn't have the data, that it was throwing off the median calculation for that example. So I filtered out the ones that have 0 because most of them are, in all likelihood, just bad data, not actual values of 0. So again, that's the base query we're running is all the beers that have a non-zero ABV. You notice we set the field restriction to ABV. I'm going to create a request. In Bluge, we create these using a function called new top n search. This would give me normally, like, let's say the top n results. Because I'm just doing aggregations, I'm setting n to 0. I don't care about the actual beers that match this search. I just want to run some aggregations over top of them. So I'm setting n to 0. I pass in the query I just created. Then I'm adding what's called standard aggregations. So we use standard aggregations to return things like the total number of documents that matched, the maximum score, and the duration of the search. Those are all capabilities Bluge had done separately before, but we've now folded that in to the aggregations framework, and we just call those the standard aggregations. I've added those here. We're not really using them. That's okay. Next, I define a style aggregation. Now, this is using the aggregations package. I say new terms aggregation because we know there's a style field. In this case, the field name is called style facet. And that's because it's indexed with the keyword field. But you notice terms aggregation doesn't directly take that. It has search field as the source, but it's wrapped in another source, which is aggregations filter text. So the reason for this was we have a bunch of styles, which are again also bad data that are empty strings. So I'm able to basically pull back the values for the style facet, but I'm going to filter it through this function. So this function basically says if the length of the value is greater than 0, then keep it and pass it through. So we're basically chaining together two different sources. We have a field source for the field name style facet, and then we wrap that in filter text to throw out like particular values of the style that we didn't find interesting. And then finally, that becomes the source, which gets passed back to the terms aggregation. I'm computing it over 10. So the terms aggregation will keep the top 10 by count. And you will see that in the data if we go back and look at it again. Now that's just for doing that outer group by. We also talked about the quantile. So we know the quantile is going to be taking place on the ABV field. In this case, I'm just directly using the ABV field and telling it I want to build quantiles on it. Now that's still sort of detached, right? Really, I need to add that to the style because I want that aggregation computed on the buckets that are created inside of this terms aggregation. So it's by adding this aggregation to another aggregation, the style aggregation, that it's going to get computed on those inner buckets. And then finally, that top level style aggregation I add to the request, right? So the original request is top end search with standard aggregations. I add the style, which has the ABV calculation inside of it. It's complex, but it's complex because it's powerful. This really allows you a lot of capability. Finally, we execute the search. And again, I print out the total hits, and then I iterate back through the results, and then I have to pull the values back out. Again, I don't want to spend too much time in this talk going into the syntax by which we pull the data values back out. But here you see I'm pulling out the 50% and then the 99th percent, and then I just print them out. And that resulted in the data you see here. Again, it was computed over the top 10 by count. That's why the counts are descending here. And that's how we get the values. So again, very powerful aggregation framework. And the cool thing is all the aggregations are, again, interfaces. So the ones we give you are, we think, useful, but the real power is you can compute your own. You have some new aggregation you want to compute, that's possible with this new framework. Now, again, this also was illustrating that we were able to run a search outside of the process by accessing, again, that most recent snapshot on disk. There's one other thing we can do while it's still running. I'm going to take a backup of the index just to show that we can. Right now, the beers index is called beers.bluge. If we just take a peek inside of that, we'll see there's 3 segments and a snapshot. And then again, the PID file, which is that first process holding the lock on the directory. But if I'm going to just go ahead and create a new directory called backup, and I'm going to run beer search, and there's another argument called backup beers2, and it takes another directory, and I created the directory called backup, so we'll just invoke it with backup. And now if we look in our backup directory, we've got a brand new copy of that, right? We've got the same segment files, the same snapshot file have been backed up. Now you notice the file sizes are different. That actually makes sense because of the particular example. So the sizes of the segments will be unchanged because those are immutable, but the sizes of the information in the snapshot itself do change. It has to do with the way that the roaring bitmaps are compressed. And I can give a deeper explanation later, but that's the short. I only called that out because I had noticed at one point that like, wait a minute, the file sizes are different, and it was the roaring bitmap compression. I think when you write it out the first time versus you read it back in and write it out a second time, it optimizes something along the way. Is, I believe, the answer. So again, the cool thing is we're able to do an online backup. We didn't stop the index. We could have been indexing data on this side. This would have simply backed up the most recent snapshot to the directory that we passed it into. So that's pretty cool. One other thing in the code I just want to mention, because I talked about it earlier, was the virtual fields. So in this code, we have, let's get to the main function here. So here is the code where we open up, we define the beer configuration. So Bluge, we can get the default configuration for an index at a particular path. That sets all of the defaults that most often you would want to use. Again, in this case, for a index on the file system. And then we're just going to say with virtual field, we're passing in this field type beer. And you notice this field type, it's defined using the exact same field definitions we would use for a document. So again, this is just a new keyword field. I'm saying the name of the field is _type. and then the value of that is hard coded the beer, right? So all the documents in the beer index will all behave as if they had a field called underscore type and the value beer. I set that to be stored so that I can pull it back and retrieve it. And I set it to be aggregatable so that I can basically run faceting information on it as well. Just to, again, quickly show you that this is real, if I, under name Bud, we notice there's, okay, that's only pulling back beer. So let's do a more general thing. Let's type water. So that matched four breweries and one beer. If I say underscore type beer, oh, sorry, I forgot this is defaulting to disjunction. So I wanted to do an and for this example. So I need to have the plus for both those. That will give me the one beer that happens to match the term water. So again, virtual field, not actually physically in the index. If you look on the file system, you won't see it there, but it behaves as if that field is there. I think a pretty powerful feature. So that sort of wraps up the demo. Let's bring this full screen again and sort of wrap things up. So what's the plan going forward? So today we launched the developer preview. The code is up on GitHub. I've been working all morning to sort of polish and get some of the integration tests running and everything. Give me a few more hours on getting all of that ironed out, but the code is live. You can play with it yourself right now. There will be a developer preview 2. We have our major feature that we have planned for developer preview 2 is overhauling the way numeric fields are indexed. That will include dates and geopoints as well. We'd like to use the BKD tree approach that's used by Lucene. Obviously, we want to address some of the feedback that we get from developer preview 1. And we really want to start wiring up integration and performance testing. We know that's important. We know that along the way, we've lost a couple things in terms of getting the API and Bluge features to work the way we want. So we need to get all that wired up and brought back. Our goal is to be production ready in early 2021. That's an aggressive goal, but that's the plan. Some of you are wondering again, should I switch to Bluge? Should we backport features from Bluge to Bluge? I think both are reasonable paths. I think in practice, it's going to be both. I think some people will want to use Bluge as it is today. Some people will want to have features backported from Bluge to Bluge. I think both can be done in parallel, and we'll see what the future holds there. I have additional sponsor Zoom sessions planned. So this was the first session to introduce everything. I'd like to spend one where I go deeper on aggregations. I'd like to do one where I go talk a little bit more about those internal index changes, like the directory abstraction and the file locking. And then a fourth one, maybe to do with scoring. We'll see about that. Open to ideas. Feel free to make suggestions as well. And again, just to set some expectations. The API will have breaking changes while we're in this developer preview phase. The file format will have breaking changes as well. So you do not ship this to production. Do not expect backward compatibility. This is a developer preview. There will be a second developer preview. Use GitHub to provide feedback. Right now, we already have a list of issues we're tracking for DP2. So please feel free to add things and we'll get those categorized and scheduled accordingly. Communication is still open. Like if you guys want a Slack channel, if you want a Google group, I can set those up. I've sort of waited because I don't want to like engineer this. If it's a small group and we want to do it in a different way, I'm open to that as well. So you guys let me know what you want in terms of making that work. And finally, I have to again thank my sponsors. Bluge is made possible by sponsors. Couchbase is the corporate sponsor right now. I'm looking for more corporate sponsors to keep this thing running and make this self-sufficient. I'm also thankful to the individual sponsors. I've called you all out here by name. Your contributions help as well, and it's great to see support from the community for this work. But again, in order to keep making Bluge possible, we need to ramp up the sponsors. So in particular, if you have a company that you know is using Bluge or interested in Bluge, please encourage them to consider sponsoring. I think this is really important work. I'm excited by it, and I hope to be able to keep doing it. So with that, I want to thank everyone again.